Hi everyone, my name is Mariana. I'm a junior major in chemical engineering and welcome to my presentation on fan-centered cubic structure. An important question to address is how atoms that compose periodic elements and other molecules are packed together to form solid structures. So crystalline solids are examples of this packing that consists of 3D arrays, as we can see here in these three examples. These structures are usually very dense, and because of that, they have lower energy compared to other models. Some materials that are classified as crystalline solids are metals, ceramics, and some polymers. These solids can be divided into 4 different structures, as we can see here on the left. So we have simple cubic structure, or SC, cubic body-centered, or BCC, cubic face-centered, or FCC, and last one, hexagonal. So the face-centered cubic structure is the most common among all the other types of crystalline solids. It has 12 coordination points, which means that each atom has 12 nearest neighbors, and it has 4 atoms per unit cell. We can see these atoms here in the picture. We have 1/8 of an atom in each corner, and as we have 8 corners, we get 1 atom for that. Also, we have half of an atom in each face of the cube, and as we have 6 faces, we get 3 atoms. Summing these numbers up, we get 4 atoms per unit cell, which is this cubic structure on the left. The FCC structure also has the maximum atom packing factor, or APF for short, which measures how much of the volume of an atom can be packed into the volume of a single unit cell. Here's the formula to help visualize this measurement. So we have 4, which is the number of atoms per unit cell, times the volume that is occupied by a single atom, in which A is the length of one face of the cube, and the square root of 2 times A is the length of the diagonal of a single face of the cube. All of this divided by the volume of a single unit cell, which is simply the volume of a cube. Here are some examples of materials that are classified as face-centered cubic structures, such as aluminum, calcium, gold, and nickel. So finally, to wrap up my presentation, I'm going to show a 3D model of this structure, which was done through SolidWorks. So this is basically what we've seen in the previous slides, and here we can take a closer look at how these spheres, which represent sections of an atom, were cut off to create a FCC structure. So I mentioned the Apf formula, which consisted of the atoms per unit cell. So as I've said, we have 4 atoms per unit cell in this FCC structure, and we can visualize better here. So this section here represents 1/8 of an atom, and as we have 8 corners, we get 1 atom because of these 1/8 sections of an atom here. And also this section here represents half of an atom, and we have this in each face of the cube. And as we have 6 faces, we get 3 atoms, because half times 6, which are the number of faces here in the cube, gives us 3, and then 3 plus 1 gives us 4, which is the number of atoms per unit cell that we have in this example of this structure. So this brings me to the end of my presentation. Thanks so much for watching.